The thirst for analytics has never been greater as organizations look to leverage vast troves of data to better understand their business and their markets. But the scale of today's information landscape is so much greater than ever before. What's an enterprise to do? One solution is to go hyperscale. Check out this episode of Future Proof to hear from CEO Chris Gladwin of Ocient about the world's first hyperscale data warehouse.
The future is here already. It's just not evenly distributed. Yet. Today's world teems with innovation. The nexus of hardware, software, and human ingenuity promises a revolution in possibilities. What does tomorrow look like? Witness Future Proof.
Got my good buddy Krish Krishnan from Sixth Sense Advisors. We're working on some cool stuff these days. And we have Chris Gladwin, the CEO of a company called Ocient that is fundamentally changing the data warehousing landscape. So we're going to dive into what that all means for you, how it's going to help you get your business done in the near future. And really, I wanted to talk about the evolution of data warehousing. So Chris and I are old enough to remember all the different eras we've gone through. It used to be that a data warehouse took you 2 years to stand up, or sometimes a year if you were very good at it, cost you millions of dollars. Don't even bother trying unless you have that kind of expense. And then things started to change. We went through this whole Hadoop world that we've talked about on the show many times, where people thought, oh, NoSQL, is that not only SQL or is that NoSQL? They thought that that MapReduce, which is how Yahoo indexed the web, could be used to do a lot of fun stuff with data. And they did. There were some interesting use cases that came out of that. But then cloud storage dropped precipitously in price, and that kind of killed the value proposition of Hadoop, which was already a bit of a kludgy environment. And then what happened? We had this massive resurgence of SQL. So for those who don't know, SQL stands for the Structured Query Language. It is the lingua franca, if you will, of database query languages. It's how you query a database to understand what's in it. And this whole surge came out with a company called Snowflake, which at the time had, I think, had the biggest IPO in this industry ever. Now that's come back down to earth a bit. And then you've got this company, Databricks, that comes along. Then you've got Amazon Redshift. There are all these different ways that you can slice and dice data and do your data warehousing. So what makes sense for your company? And then this new company, Ocient, comes along, not exactly new. They were on version 19 a while ago. I think they're in version 21 now, which shows you the maturity of the platform. They came up with something called a hyperscale data warehousing. So what does that mean? Well, the cloud gives you this hyperscale capability, right? So people started to understand that Google and Amazon and Microsoft, they're the hyperscalers for being able to deliver functionality at tremendous scale that can scale up. Increasingly, it can scale down. That was a bit more of a challenge than scaling up. But what does that mean for data warehousing? Well, we have the man to explain all of that, dialing in from my old haunt of Lamont, Illinois, Chris Gladwin of Ocient. Tell us about your vision and what is hyperscale data warehousing?
Hey, Eric, great to be here. Chris, great to talk with you. So hyperscale is a term that I think's been used at different times because it changes in its meaning. What we're seeing is what hyperscale means in data analysis is it's the point at which the scale of the data analysis dictates a different approach. You can't just take the normal kind of middle of the road and say, well, let's just make it bigger. There's a point at which the scale of your data analysis benefits from an approach just for hyperscale. So that's one thing we see. And where we're seeing that in the market is generally when the average amount that you're analyzing is about a petabyte of data. So every time you run a query, it's got to look at a petabyte. And you do that a lot, and you're doing kind of complex things. And in terms of numbers, what we're seeing is we have gone through the process of identifying what are all the data sets in the world with business requirements that need that. And we're seeing it's about, on a dollar basis, it's about 4% of the overall $210 billion data analysis market. So it's about an $8 billion market, growing really fast. It's growing not only because the data keeps growing, but the number of use cases that need that approach is growing. So it's growth on growth. So it's growing about 35% a year to about $35 billion in just 5 years. So that's the market. And then you get into like, what's in there? You know, what is the kind of data that needs this? And certainly we're seeing the biggest source of that is telecoms themselves. So if you're a telecom, your network is giant. And there's all kinds of reasons why you want to analyze what's going on. It could be compliance requirements you have. It could be capacity planning, troubleshooting, performance optimization. But to really do that, you got to look at all the metadata that flows in your network to see what's happening. And the amount of metadata that a telecom makes is crazy. It's not trillion scale. It's hundreds of trillions, and quadrillions is the next number. That's actually what they want to analyze. So that's just a little flavor of kind of what hyperscale means.
Yeah, you bring up an excellent point, because there are these inflection points in the industry, right? And so historically, you'll see things like that's where appliances would come into play, right? When the software can no longer handle it by itself, you do an appliance, and then you're leveraging the power of the hardware and the software. And then, of course, that kind of changes again, and so you innovate on the software. And as my business partner, who's mostly retired now, Robin Blorwood, once pointed out, all the innovation starts at the hardware level. At some point, some new piece of hardware changes things. And we were talking before the show about solid state memory. And if you look at, there's a lot of interesting threads we could pull here, but you look at Hasso Plattner, and this is a bit off topic, but he saw like 20 odd years ago, 25 years ago, he said, you know what, memory, like solid state, is going to come down in price over time. And at a certain point, it's going to cross with data stored on disk. And so they pushed SAP into this whole in-memory world. Well, it's before Kubernetes came out. And so now they're, kind of sitting on this monolith in a new distributed world. It's a bit of a different challenge. But he saw that coming, and you've kind of seen that coming too, right? Because the capacity of these flash and these solid state drives to deliver data much, much faster with less trouble is a big deal. So, but figuring out how to build the infrastructure to leverage all that, well, that's what you guys have been working on for 20 odd versions, right?
Yeah, we saw that coming almost exactly 10 years ago. The revolution that's happening in solid state wasn't something you could hide, because it literally was close to a $50 billion investment made by semiconductor manufacturers like Intel and Samsung and Toshiba. Like, that doesn't hide in a corner. That's like $10 billion fabs and thousands of engineers and, lots of academic papers. And it took a long time. And so one of the things that's different, though, about this, what I would argue, it's the first new building block in computing ever. You hard drives, and they got bigger, and DRAM got bigger, but solid state, it's not a faster spinning disk. It's not cheaper DRAM. It's different. And, you could see it coming from a decade away. And unlike most of the time, or I think pretty much I'm curious what y'all think, but I would assert that this is the first new semiconductor change that didn't start like in supercomputers and work its way down. It went the opposite. Apple is a phone manufacturer, device manufacturer, and Samsung also saw this coming, and they got in the production. They were investors in the fabs and the fab companies, and part of that was like, I get first crack at it. So what we saw as a company completely dedicated to building a data analysis platform on solid state, and we have friends. I mean, we've been doing this for a million years, and there was a point where it was in your phone. It was in like billion unit production scale in consumer product, the phone, the laptop, and we, as the leading technology creator for hyperscale data analysis platforms, we could barely get our hands on samples. It just wasn't in production. Like, consumers were first.
Wow.
And then what happened? And then you had the supply chain issues with COVID, where, that just made it really hard to get something unless you had a guaranteed contract.
Right.
And then about 12 months ago, it changed. Now you want 1 million, no problem. Those fabs are running, they've got the production issues. And the profound change that you were referencing is what's happening now is it's gone from really hard to get your hands on to you can get as much as you want. And there's two metrics that matter. One is the cost per storage, and the other is cost per performance. And what is happening right now is, if you look at the lifecycle costs and include not only the cost of the drive, but the cost of power, because they're more efficient on power than spinning disk, the space, which costs money to put in a data center, and they're more efficient on space than spinning disk, and reliability. When something fails less often, it costs less. In solid state, fails less often than spinning disk. If you look at that life cycle cost, solid state particularly NVMe solid state, which is the parallel interface that everyone uses, it's a great standard,
Right.
is crossing below spinning disk right now.
Wow.
On a cost per terabyte basis, with currently 2,000 times the performance. And the next generation will have 4,000 times the performance, then 8,000 times the performance, and spinning disk will never get faster. So that's happening right now. And what that will cause, and it'll first happen at hyperscale, is the collapse of compute and storage tiers into one. And the only reason they were separate because there was a big price difference. And then what we can talk about maybe later is around 2030, the cost per performance, which, we were using the cost per million random 4K reads per second per dollar, solid state will drop under DRAM, under the cost for performance.
Wow.
And solid state is so early in its Moore's law curve that it is in Moore's law. Every 18 months, it gets twice as good. DRAM is not, spinning disk is not. They're kind of stuck. And so this is where we are today, and where we're headed is solid state is going to completely change, how computing is built and how data is analyzed.
Yeah, that is absolutely fascinating. I'm going to bring in Krishnan to comment on that. I mean, these are the kinds of things that engineers need to be focused on. And frankly, CDOs and CTOs and CIOs need to have in their perspective, because this is going to have tremendous impact on what you're able to do if you're not embracing this new way of doing things. But Chris, what do you think?
Oh, absolutely agreed. In fact, to highlight where Chris was taking the thought process to, if you want to think of in the next 7-year spectrum, 2030, right? What's going to change? The question is what's going to change? That's what bothers a lot of CIOs and CDAOs, not just the digital officers, but the data analyst. What's going to change? We're becoming drone driven. Everything is getting automated. Everything is becoming its own lat longs and its own points where data is going to intercept and crisscross, and what boundary is safe versus what is okay, where's public versus what's private. When you're looking at those boundaries exploding in the next 7 years, we're going to look at volumes of data, which is like, yeah, I built a 5 terabyte data warehouse. People will laugh. 5 terabyte would be like something that happens on a daily basis. I built a 5 petabyte data warehouse. Now you're going to be talking, yeah, that's good. But then we're going to be talking about 50 petabyte data warehouses. But we'll still say data warehouse, right? I mean, so to me, while the spectrum of storage is fantastic, the problem solving still has to be put on top of it so that you can tether and then get the solution stack built on top of that foundation. And to me, that's where, Eric, I think we should take our next set of discussion points with Chris is why data warehousing?
Yeah. Well, that's a good question. So I'll throw it over to you, Chris. Now you have these data lakes people are talking about. There are these large language models doing very interesting things, but it's not data warehousing for sure. And you're really focused intently on the data warehousing use cases at hyperscale to enable organizations to really slice and dice, right? Because the thing is, the faster you can cut through the data, the faster you can do the analysis and get the answers, the more questions you can ask, the more chance you have of finding the signal you wanted to change your business, right? And I think a lot of the older solutions now are frankly encumbered not just by bureaucracy, but by technical debt and sort of traditional hurdles that they're just not getting over. They're kind of running into walls. That changes behavior inside the organization. You ask less questions, you're less risky, if you will, you take fewer chances, and then you don't do as well. I mean, that's my take on it, but what do you see, Chris?
What we're seeing in customers is the compromises they've had to make at hyperscale often involve things like, letting most of the data fall off the table. I mean, they can't effectively analyze it, so they don't even collect it. Automobile manufacturers, if you have 100 million cars, I talked about telcos. For a telco prior to Ocient in this next generation of data warehouse capability that we're talking about, they really couldn't cost effectively collect and analyze all network metadata on the network. It's a quadrillion rows in a table. It just doesn't make sense. They're not going to spend $500 million on a supercomputer. And so therefore, then they end up making compromises. So if you want to do like performance analysis, you don't care about averages. All you care about is the worst. What's the worst performance on my network and what were the conditions? But that means you actually have to have all of it to see the worst and identify the things that correlate with the worst. So what we've seen where, companies would then either just not have all the data and then make the best of it. In some cases, like in ad tech, some of our customers, they would there's tens of millions of digital ads that go up for auction every second. And there's whole industries of people that either supply those inventory of ad placements or buy those and analyze those. And because, that's such a volume, if they want to back test an algorithm for some kind of campaign they're going to run on the last 3 months, well, that's just too much data. So then they would downsample it to something like 0.1% of that ad exchange. But the problem with that is, then if you had a really large customer that wanted to, test a campaign, the results become inaccurate. So what we're seeing is, because at Ocient, we're using this solid state technology, which is like game changing. It's, and going back to your comment earlier, the best you can do as a software designer is to go as fast as the hardware. And so what we're able to do is to address these problems where you can do full resolution data. Results can be accurate, even at hyperscale.
Host here, Eric Kavanaugh, talking with Chris Christian and Chris Gladwin of Ocient. Chris is my consultant friend from many, many years ago, also in the Chicagoland area. I grew up in the Chicagoland area. And, before the show, we were talking about I-355 and how I-355 opened up. And I used to be the editor for the Lamont Metropolitan newspaper. And I actually interviewed a guy from the Illinois Department of Transportation about the project at the time. And he told me something very interesting. He said that the laws do not allow you to go and build a highway according to future traffic speculation, like how much traffic you think is going to be in the future. They said you can only use the data of traffic that is currently in this region, and that's how you justify where you build these highways. Well, once they built 355, I promise you, there were all kind of people that changed their driving habits because it was so much easier to go up to the north suburbs, and it was like night and day, basically. And you can kind of make this comparison, this loose comparison of traditional versus hyperscale. Like traditional is going the back roads and hitting the stoplights wherever you go. It takes you an hour and 10 minutes to get from Bolingbrook to Schaumburg. And then the hyperscale shows up. It's like, oh, nope, you just get on the highway. There's no turnoffs. You can just keep rocking and rolling and get there in no time. It changes behavior and new things happen, and you start to change how you plan your day, because I don't have to spend an hour and 10 minutes. I can only spend 27 minutes. So these new technologies, Chris, when they come along, they open up whole new possibilities. So it's not just that you can do the old stuff 10 times faster. It's that, yeah, you can do that, and you can do all this other interesting stuff. And that's where the business value tends to accrue. What do you think?
Yeah, generally what we're seeing is by designing a new software data analysis engine for hyperscale analysis using this amazing new building block, the NVMe solid state drive, as well as some other pretty choice building blocks like high core count CPUs and 100 gig NIC connections everywhere, you really can't get to 10 times the price performance than what was previously available. And in some cases, you get to 100 times. And every time, this is not the only time there's been 10 times the price performance for some kind of IT capability. It's happened many, many times. And every time it happens, two interesting things occur. One is industry or consumers never keep doing what they were doing before and just save the money.
Right.
Never. They always find, if it's 10 times the price performance, they will find more than 10 times the things to do with it. And the pie grows bigger. I challenge you to, give me a counterexample, because I'll name everything else. So that always happens. And the other thing that's interesting, and part of why that happens, is when you look back 10 years, 20 years later at what are the uses now of that disruptive new technology, typically at least 80% are new, things that could only exist once the disruptive technology change occurred.
Right.
20% or less are what was there before becomes bigger, faster, cheaper, and more than 80% becomes only now that I have broadband can I have a giant system that distributes videos of pets known as YouTube and other silly things. Like that couldn't happen before broadband. Broadband happens, boom, here comes YouTube. And there's, many examples of things like that. Like we, in my last company, CleverSafe, we dominated the market for photo sharing, for software for photo sharing systems. Photo sharing was kind of the first incarnation of cloud storage. It could, there was this idea of like, take as many pictures as you want, we'll store them forever, and every once in a while we'll sell you a mug. Like that business cannot exist. And that's a very great business for a lot of companies. It couldn't exist until the price performance of, super reliable photo storage systems at hyperscale went down about 100 times. And you just, you just see example after example where when these big disruptions occur, all kinds of new innovation happens.
Yeah. No, that's exactly right. And I love the comment you made of, when you do get this increase in performance, never do they just save the money, especially in analytics, Krish, because in analytics, again, you're trying to understand your business. And so now when you have these new tools to dig deeper into your own data to understand, like you take the telco example, that's a big deal. If you can problem solve faster and figure out how to fix this issue, you're not going to lose 1,000 or 2,000 customers to your competition, for example. Just little things like that really add up quickly. But it's the case across the analytical spectrum. The more you can analyze, the better off you're going to be. And the fact is that some of these old solutions, even though Teradata, for example, I'm told just spent $250 million to refactor their entire engine to run in the cloud and Amazon Web Services. Now they just rolled out for Microsoft recently. That's a lot of money to spend refactoring. But Chris has some interesting thoughts about Kubernetes as well, because with Kubernetes, you're federating all this compute, which, I've always joked we sacrifice state at the altar of scale to be able to do these things. But still, there are inefficiencies baked into that system as well. So if you do your job right on the Ocean side, there's really not a lot of benefit to get from going into a Kubernetes environment. All you're trying to do is enable your analysts to crunch data. Chris, I'll throw it over to you first, and then we'll get Chris.
Yeah, and the point you're bringing about the availability of valid data is very essential, right? I mean, for many years, we've all gone in the traditional route where we've said, yeah, this model works, or no, this one doesn't, or while a bridge table suddenly becomes a point where data just goes crisscross, all kinds of issues that have been faced for a number of years where analytics could not succeed because of the lack of data in the bottom line.
Right.
That is something that I would love to hear Chris talk about, because hyperscaling would mean now your data fabrication. Right? This is a term that Ocean would love to talk about with a good definition. So Eric, if we can get Chris to give us a quick definition on what the data fabrication thought process is, and then we talk more about why then bringing the analytics use case or anything else is going to be so much more easier for folks to understand. But that's the bottom line. That's the grassroots that we want to get to. Chris, over to you.
Yeah, Chris, go ahead.
I think the other big change we're seeing in data analysis, kind of from a traditional, even the kind of recent generation of data warehouses like Snowflake and Databricks and Redshift, is a shift from kind of traditional batch-oriented data loading to data never stops streaming at scale. And the database now has to exist in this environment where data is constantly growing. And that, one of the challenges is taking, terabits per second of input data, which is never in an easy to digest state, and getting that transformed from some typical semi-structured, messy state into relational schema that is indexed, secondary index, compressed, encrypted, and showing up in queries within seconds. That traditionally has not been possible either. And that's another thing that we were able to do at Ocean, because it's also interesting to think about, where does data come from? And at hyperscale, 0% of the data comes from typing. People don't type at hyperscale. Just to give you a sense, a minimum system for Ocean would be, a petabyte, a trillion rows in a table. A trillion, if you print it out, circles the earth 73 times. And if you were to scroll it, 2 pages a second, assuming you could see data that fast, it's centuries to just scroll through that table. Like, that is not something that humans can create, and that is not something that humans can even read. So a couple changes there, in that all the data being analyzed at hyperscale is machine generated. It's routers, it's cars, it's satellites, it's instruments. And then the other big change is we've entered this time. I mean, it used to be like, if you really had to look into something, you could go look at the logs. You could actually go look at the data. Like, you can't go look at the data anymore. Human beings cannot see data at this scale. They are now completely dependent on these tools that look at the data for them. And an increasing amount of what people are using is machine learning, artificial intelligence to characterize that for them. I mean, I can't look at everything. So just go look at these 100 trillion things and tell me what's 4 standard deviations out of normal. And maybe I can look at that, but I can't look at the raw data ever again. So those are a couple giant changes we're seeing.
That's funny. You have a couple great quotes in there. I can't look at the raw data ever again. That's a funny thing. And let's talk about observability too, because you were just kind of referencing that. Observability is this huge space now that has blown up for lots of different reasons. But to your point, with observability, you've got all these signals of data that's streaming constantly. And what you're trying to figure out is how to apply the appropriate filters to get signals when necessary. So you mentioned like 4 levels of deviation, for example. Can you talk about how you're able to leverage data warehousing technology at hyperscale in order to enable meaningful observability across these systems? And there's also the issue of cloud environments, which have lots of different things going on. It's not just your ERP you have to worry about, or one database. It's lots of different things interacting in real time to push this stuff forward. So talk about how you're able to help people understand what's happening in that world and how that actually works.
Yeah, an increasing amount of what's happening is what's happening right now. You can't just be, data was, fresh from yesterday. It's got to be fresh from 3 seconds ago. And so, so much of what you want to understand involves this fresh data. So it's sometimes just looking at that data itself, and sometimes it's looking at that data comparison to older data, but it's less and less just looking at older data. So this, real-time analytics capability that we've incorporated at hyperscale into our platform is essential. And all of our customers are using it now because all of them have, this need. And the big unlock we're seeing in there, just like we're seeing in the data analysis at hyperscale, is using machine learning more and more to tell you not only what is in the data that's pouring in all the time, but how to deal with it. It takes, there's so much coming in, it's changing so much that we're using AI more and more to help us load and characterize the data as it streams in.